Hello, good morning. Show the cameras, please. Alright, mela. Okay. Nispera l-biraħ kulħadd alright bil-test. Mela, issa ħankomplu ovvjament Rotational Dynamics. Ovvjament issa qed nippjana li għal holidays, ġifieri issa għandna l-ġimgħa d-dieħla daqs u mbagħad nibdew li jsir holidays. Ħantikom daqsxejn il-homework ta' circular motion, equilibrium. Naħseb Rotational Dynamics forsi dak ma ntikomx, mbagħad intiħolkom wara. Mbagħad intikom riskin kella. Alright, imma għal holidays definitely ħajkolkom ftit homework. Alright, mela, ħankomplu dak li konna nitkellmu fuq l-aħħar darba. Mela, ħanaqleb waħda fuq il-whiteboard. Mela, attentiex kif tafu maħniex nagħmlu affarijiet sempliċi ħafna. Alright, l-affarijiet issa tikkomplikaw daqsxejn, ġifieri moħħna ftitaw. Mela, li qed ngħidu huwa in simple words that whatever we discuss for linear motion, we are converting it for rotational motion now. Alright? We are converting it for rotational motion. And therefore, what we did, we are discussing angular acceleration. So angular acceleration is what happens when the angular velocity changes. Alright? Which is something rather new for us, because in circular motion, the angular velocity in most cases was always at the same constant. Alright? So now the angular velocity is changing. If the angular velocity changes, therefore you have angular velocity. Therefore we need a set of formulas, as we had in linear, to be able to find angular velocities, time, etc. So what we did was we changed all our physical quantities. ħanerġgħu narawhom ftit dawn x'importanti. So mass, instead of mass, we're using moment of inertia. Instead of u, we're using omega naught, initial angular velocity, v, omega, final angular velocity, instead of a, alpha, angular acceleration, tt, because time is not linear rotation, instead of s, which was the displacement, we're using theta, the angular displacement, or else the angle in radians. Alright? Therefore, next, we changed all those formulas in the rotational form. So they are exactly the same formulas, but using the rotational, ħanejdulhom hekk physical quantities. The link between the linear and the rotation, because there's a link, because if you have an angular velocity, there is a linear velocity for tangential velocity for the particles. If you have an angular acceleration, there is a tangential acceleration. So there's a link. The link is these two equations. V equals omega r or A equals alpha r. Alright? Which links V to omega and A to alpha. Alright, so what are we going to do today? So after discussing angular acceleration, now the next obvious step is if I have an object, alright, which can rotate on itself, and I want to increase its angular velocity, mela omega naught and omega. Ġifieri da per eżempju kien wieqaf u mbagħad ħanibda ndawru naġlu iktar. Jew inkella tjaġġel u mbagħad ħajibda jislowja. Dak huwa a change in angular velocity. Therefore I have an angular acceleration. What do I need to do to the object in order to provoke an angular acceleration? In linear motion, in order to provoke an acceleration, what would we need to exert on the object? What did we need to exert on the object in order to obtain a linear acceleration? A force, a resultant force. Taqblu miegħi? A resultant force. So, let's try to apply a resultant force on this object in order to provoke an angular acceleration. Tinsewx din hija Newton's second law. Newton's laws japplikaw dejjem. Mhux għal linear biss, alright? Ġifieri dejjem japplikaw. So in order to obtain this acceleration, we need a force, a resultant force. So let's say that I'm going to apply a resultant force in this direction, like this. Alright? Will that force provoke an angular acceleration? What do you think? Taħsbu li dik il-force ħatibda ġiel dal-oġġett jiżid l-angular acceleration? Le, għalfej, because it is pointing towards the center, ux vera. How should I apply that force in order to provoke an angular acceleration, in order to increase the angular velocity? Isa, aħsbu. ċerrit nagħmel? Ejja, Isa, come on. Tajjeb, eħe. I have to apply a resultant force. Ġifieri li għal Newton xorta tibqa' tot. But in rotation, in order to acquire an angular acceleration, inti jekk għandek oġġett, daw provaw immaġinaw affarijiet reali, immaġinaw għandek oġġett. U huwa pivoted fin-nofs. Ma nafx, palissa tiġini f'moħħi tgħidu li xkif. Din ir-rota li jużaw fil-fieri, tafu li met ngħid. Li d-duru insomma mbagħad tirbaħ meta tiġi fuq xiex tiġi. Jekk dir-rota nipprova nimbutta jien lej iċ-ċentru u l-iktar nista' nagħmel naqla r-rota minn ġo posta, u vera. Għaliex? Ara kollox physics għax noħloq linear acceleration. Alright? Biex noħloqlu angular acceleration biex jibda jżid l-angular velocity, il-push irid intija tangent din hija kollox. The resultant force the resultant force should be applied tangent to the circle, like that. So I'm still applying a resultant force, but it is tangent to the circle. So it's 90 degrees to the radius. Now, when I have a force, kulla ħarftit qudiem il-computer. Għalli kif xismu tibda. The force should be applied 90 degrees to the radius. Alright? 90 degrees to the radius. Therefore, when a force is being applied 90 degrees to the radius, in fact, I'm not applying a force, I'm applying what? What is the force times the perpendicular distance from F to the center? What is this called? Diġa minnija? Ejli Susanna, ma smajtekx. Moment of a force. So, instead of a resultant force, in order to provoke angular acceleration, I need a moment of a force, so the resultant force should be applied tangent to the circle, such that this provides a turning effect. U dik hija, I need a turning effect in order to start accelerating angularly the object. Tarawa kollox jagħmel sens as such, okay? So, the moment of a force, the definition of moment of a force, nurijilkom hawnhekk. Nurikom ftit il-PDF, in-notes. The moment of a force, the turning effect of a force is known as the moment of a force. So, the definition of moment of a force is the turning effect of a force. So, when a force provokes a turning effect, mela provokes in this case, in other words, an angular acceleration, that is called a moment of a force. Tajjeb sawnek? Sawnek, alright? Mela we don't need a resultant. A resultant force is not enough in this case. In this case, what we need is a turning effect, therefore a moment of a force. Issa. As I have already said, as I have already said in the previous topic, in that short topic, equilibrium, since the force and the distance, they have to be perpendicular, if the force, as I have in this diagram here, is not perpendicular to the distance, then you have two things that you can do in order to calculate the moment of a force. Either open up the force in components and use the perpendicular component times the distance, or else leave the force as it is and you have to search for the distance, you have displacement here, which is perpendicular to the line of action of that force. So it's either F times OB or F sine theta times OA. Both of them will give you the same moment of a force about O. Ok, di diskutajnija diġa li qed naġġela ftit. Ok, għax konna diskutajnija diġa. Tajja. Ħankomplu issa. Now, when you have an object and you apply just a force perpendicular to the radius, to the direction, all right, like that, what happens is that actually that force is doing two things at the same time, if you can see it. There is a moment of a force, because we have force times perpendicular distance. Sorry? Alright, Damien, alright. So, you have a moment of a force, therefore you will have an angular acceleration as usual. In fact, it will start rotating on itself. But if you look closely at this diagram, you can identify that there is a resultant force as well. Ara, if I draw a free body diagram of this object, I just have that force acting on it to ġver in that direction. Therefore, that force, since I have only one force pointing in one direction, besides angular acceleration, because I have a moment, that force is also acting as a resultant force on the object. So the object will, at the same time, perform, linear acceleration. So if you apply, and I have already done this before, if you apply on an object just one force, and the center is here, and just one force, this object will start rotating, okay, because you are applying a moment of a force. But at the same time, you are applying a resultant force, so it will start rotating and moving linearly at the same time, because you have both of them. You have a resultant force and a moment of a force, so you have angular and linear acceleration. Therefore, the next question is obvious. So what do I need? How do I need to apply the moment of a force in order to provoke only angular acceleration? Only angular acceleration. So, let's see. So I'm going to draw the same object with the same pivot, and I have the same force here at a distance r. Tell me what should I do in order to provoke angular acceleration. Angular acceleration irida xorta. But I don't want any linear acceleration. Ġveri jina rrit niprovoka moment imma mhux resultant force. Moment imma mhux resultant force. X'taħsbu li nista' nagħmel? X'irrid inżid biex inkun nista' nagħmilha di? Ħadmu daqsxejn moħħkom. Isa. Pruvaw aħsbu ftit. Ħanejnkom, għajli Matthew? Le, xorta nibqaw l-istess. Mela ħanejdilkom di, ħanejnkom ftit. Biex ma jkollix linear acceleration, x'ma jridx ikolli? X'irid inneħħi bil-force biex ma jkollix linear acceleration? Isa. Jena biex ikolli linear acceleration, daw suppost huma affarijiet issa lkom tagħmlu anke mill-low level li għadnija rġajna għadnija dis-sena. Biex ikollok linear acceleration, x'għandek bżonn? X'irid ikun hemm fuq il-oġġett? Isa. Come on. Għadni kemm għattilkom, taf titilu. U ħdimnija u ġajt semmejtilkom. Biex ikolli resultant force, x'għandi bżonn fuq l-oġġett? Irid ikolli xiex? Resultant force. Mela jekk jien rrid inneħħi linear acceleration, qegħdin moħħkom hawnki. Daw affarijiet li għamiltuhom hija għamiltuhom qabel ta'. Issa qed suppost qiegħed nibbildja fuq dak jiena, jekk intom ma tafux l-affarijiet bażiċi kif ħan nibbildjaw fuq l-affarijiet iktar komplikati. Isa, tinkwetawniex ta'? Mela, ħankomplu. Mela, biex ikollok linear acceleration, irid ikollok resultant force. Mela jekk inti ma tridx linear acceleration, trid tneħħi resultant force. Biex ma jkollniex resultant force, x'irridu nagħmlu? Jekk għandi din il-force, x'nista' nagħmel biex inneħħi l-effett ta' din il-force? Nagħmel force oħra kif? In the opposite direction. Tgħidli ma stenna, jekk nagħmel force oħra hawn, daw jikkanċellaw il-xulxin u la linear acceleration ma jkolli u laqqas angular acceleration għax tikkanċella kollox imma jekk nagħmel hekk araw, attenti. Stenna. Jekk nagħmel hekk araw x'għamilt. Ara x'qed jiġri. Din il-force u din il-force qed jibbilanċjaw il-xulxin qed tarawhom. Jekk nagħmel an equal and opposite force, but which is anti-parallel. Xi tfisser anti-parallel? Ġifieri these two forces they are equal in magnitude, but they are parallel to each other, mhux in line, parallel to each other and anti-parallel, ġifieri in opposite directions. If you have this type of system, araw x'jiġri. I don't have any resultant force. Għadin tinnotaw? I don't have any resultant force because this force and this force they are cancelling each other, so I don't have any resultant force in this case. Sawnek, alright? Edin miħaj sissa hi. Edin miħaj sissa. So I don't have any resultant force, therefore I don't have any linear acceleration, but I have moments. In fact, I have two moments. Look, I have force times the perpendicular distance. So here I have a moment, an anti-clockwise moment. And here I have a force and a perpendicular distance, so I have another clockwise moment, anti-clockwise moment. Therefore, I have two moments which are helping each other. So a moment I have. If I have a moment, I will have angular acceleration. But at the same time, since these two forces are acting in opposite directions, they are cancelling each other linearly. So linearly, I don't have a resultant force. Therefore, I don't have a linear acceleration. This type of system, when you have two forces which are equal and anti-parallel, is called a couple. U hija sempliċi għaliex ngħidula couple u x'vera, għax qed jaħdmu flimkien. It's called a couple. Now, therefore, a couple, the definition of a couple is made up of two forces which are equal and which are anti-parallel. So anti-parallel means that they are parallel to each other but pointing in opposite directions. And that is a couple. So if you apply a couple, you will have only angular acceleration without any linear acceleration. Therefore, in other words, so if I have a fan, a ventilator, li nużaw fil-sajf, alright? A fan, a ventilator, you need that fan, when it starts rotating, it rotates having angular acceleration, but no linear acceleration. Taqblu miħaj? So in that case, you need to apply a couple. Alright? That's easy. Okay? If you have a wind turbine, you need that the wind exerts a couple on the wind turbine because you need the turbine to turn to create an angular acceleration. It will start rotating and increasing angular velocity, but you don't need linear acceleration. Ux vera. And we can continue on going like this. In fact, in many engines, you need couples. Not just a moment of a force, but you need a couple. Alright? Two forces which are acting in opposite directions and producing therefore a couple. Edin niftehmu jawle. Okay, sawnek, alright? Issa. Mela, skużawni waħda dal-waqt. Mela, okay. So a couple is made up of these two forces which are equal and anti-parallel. Sawnek kulħadd alright? Sawnek okay? Issa. So, how are we going to calculate the moment of this couple? Actually, it's very easy, because here we have two moments which are helping each other. So if we need to find the moment of this couple, all we need to do is calculate the moment created by one force plus the moment created by the other force. Plus, because they are helping each other, they are in the same direction, anti-clockwise. So, if I want to find the moment of a couple, all I have to do, ħanamel sistema daqsxejn iktar in general. So if you have two forces which are equal and anti-parallel, and let's say that the distance to the pivot is A from this force and from the other force is B, all I have to do is the moment of the first one, għandek F times the perpendicular distance A, plus the moment of the other one, F times the perpendicular distance B. It's very simple. As you can see, since F is the same, because this is a couple, so they are equal in magnitude, I can put F common, so out of the bracket. So F into A plus B. Remember that A plus B is this distance. So actually, in order to find the moment of a couple, you either find the moment of each force and add them together, or else what you can do is, as you can see here, you can multiply the magnitude of one of the forces times A plus B is the separating distance between the forces of the couple. Qegħdin tifhmuni hawnhekk? Between the forces of the couple. Ġifieri jekk inti tagħmel force waħda times the separating distance, xorta waħda tkun sibt il-moment of the couple. Now, the moment of a couple has a special name. All right? We call the moment of a couple a torque. We call the moment of a couple a torque. And it has also a symbol. The symbol of a torque is T in Greek. And T in Greek is the letter tau, which is written like this. Attenti, għax tisbaħ ħafna T normali li namlula hija il-horizontal line, we make it a swirl, insomma, we make it a little bit swirly, and even the vertical line, we bend it as well, alright? Dik tiġi tau, that's the torque. So torque is the moment of a couple, therefore the torque is equal to the force times the perpendicular distance between the two forces that you have. Tant nużaw għat-torque li ħafna drabi nispiċċaw flok nużaw il-kelma moment, ħafna drabi nispiċċa nuża l-kelma torque mill-ewwel. Alright? Il-units ta' torque huma bħal units ta' moments because it's practically a moment, ġifieri il-unit jiġi Newton meters. Alright? Pas-soltu. Infatti, meta jkun hemm engines, car engines, etc., ħafna tipi ta' engines, dejjem fil-specifications tagħhom ikun hemm it-torque. Għax it-torque huwa importanti ħafna. Għax inti mhux kemm il-magna ddur fast hija importanti, dik importanti kemm kapaċi tagħmel revolutions per minute hija l-frequency, dik importanti, infatti dik tkun fl-specifications ukoll, the maximum revs per minute li tista' jkollha. Imma mbagħad tittara kemm b'saħħitha. Jekk inti jkollok mutur kapaċi jagħmel ħafna revs per minute, imbagħad kif tqabdu ma' xi ħaġa daqsxejn jibsa jislowjalek, dik għalfejn għax ma jkollux biżżejjed torque. Mela jdur fast, imma the force times the perpendicular distance mhix kbira biżżejjed, mela m'għandux biżżejjed saħħa. Infatti pereżempju, diesel engines li nużaw għat-trakkijiet, normally they have a larger torque than petrol engines. Alright? Għalhekk nużaw id-diesel engines fuq it-trakkijiet għax b'saħħithom ħafna iktar biex idawru. Imma mbagħad mhumiex kapaċi jtellaw ir-revs per minute li jtellaw petrol engines. Alright? Dik hija r-raġuni li għala petrol engines nużaw fuq karozzi ħfief żgħar, fuq karozzi tqal nużaw mbagħad id-diesel engines. Alright? Ġifieri dawn l-affarijiet issa rridu nibdew nagħtu kasom. Hemm film ukoll torque fuq moturi. Issa ilu ftit, qabel kif kont ngħidlek kienu jgħidu le iva rajnieh, issa għadda. Kulħadd qed ixjieħ. Mela, alright hawnhekk tajjeb, issa. Okay, mela, l-aħħar ħaġa fuq couple, l-aħħar żewġ affarijiet fuq couple. Mela, x'qed ngħidu hawn mela? Mela biex oġġett ikollu angular acceleration biss għandek bżonn couple. Alright? U l-couple bit-torque tiegħu ikun jista' jdawwar, etc. Mela allura din taħdem both ways issa. Xi tfisser? Ġifieri jekk taraw oġġett li qed jagħmel angular acceleration biss qed idur fuq innifsu biss u jaġġel fuq innifsu biss, dik ifisser li bil-fors hemm couple, bil-fors. Jekk taraw oġġett li qed idur fuq innifsu u fl-istess ħin miexi linear li wkoll mela qed jagħmel iż-żewġ tipi ta' accelerations, angular u linear, mela allura tfisser li hemm couple fuqu għax kieku mhux qed jagħmel angular acceleration. U fl-istess ħin hemm imma resultant force ukoll. Ġifieri issa moħħna nistgħu ħanejdu hekk inqiegħdu kollox b'mod ordinat. Mela jekk taraw oġġett li qed jagħmel angular acceleration dak għandu couple fuqu bil-force. Jekk taraw oġġett li qed jagħmel linear acceleration dak għandu resultant force fuqu bil-force. Jekk taraw oġġett li qed jagħmel angular acceleration u linear acceleration fl-istess ħin, dak ifisser li fuq u bil-fors hemm couple u fl-istess ħin għandek ukoll resultant force. Qegħdin niftehmu saw? Mela, ħan nieħdu ftit eżempji, qed insemmilkom daw għax daw l-eżempji naf li jistgħu joħorġu anke fi questions. Ħalli nippruvaw nifhmu daqsxejn l-affarijiet. Mela, ħan nieħu xi ħaġa li kulħadd żgurra u kulħadd żgur ta' kasa li hija steering ta' karozza. Alright? Mela hekk għandek steering ta' karozza, jekk tmorru titalmu l-karozza, l-ewwel ħaġa li jgħidilkom it-teacher tagħkom, ma nafx għaliex ngħidulu learner, imma insomma, it-teacher sewa, jgħidlek biex iżomm idejk, alright, mhux faċċata ta' xulxin, kieku faċċata aħjar, imma jgħidlek biex iżomm idejk insomma on both sides of the steering. Għalfejn? Ovvja, għax jekk inti tagħmel idejk on both sides of the steering wheel, you are producing a couple. Alright? The two forces, two equal forces antiparallel. U allura jkollok kontroll perfett tal-steering. Sawnek alright? Imma, il-problema hi li iktar ma titgħallem il-qudiem jew inkellek tkun qed tbiddel il-gear, ħafna drabi nispiċċaw f'ċertu każijiet nużaw id waħda biex indawru l-steering. Id waħda. Issa, jekk tuża id waħda biex iddawwar l-steering, jekk tuża id waħda biex iddawwar l-steering, okay? Hemmhekk m'għandix couple, taqblu miegħi dik mhix couple, mela suppost l-steering jekk inti ħad tiġbdu minn naħa waħda, ħajamel żewġ affarijiet taraw, hemm moment of a force mela ħajibda jdur fuq innifsu. Imma fl-istess ħin għandi resultant force il fuq. Ġifieri suppost jekk tagħmel hekk l-steering taqala u tibqa' miexi bih dritt, idur u jimxi fl-istess ħin. Għax għandek resultant force. Imma kulħadd jaf li l-steering ma jagħmilx hekk, alla ħares għax tuża id waħda taqala l-steering minn postu għax tagħmlu linear acceleration f'ġieħ kemm hemm. Imma kull ma taraħ meta inti tuża id waħda u kull ma jagħmel angular acceleration biss ma jagħmilx linear acceleration. Mela, il-physics qatt ma jkollu, aħna maħniex lingwa, ġifieri mhux l-ewwel intukom regola mbagħad ngħidulkom immissa hemm ħafna affarijiet li ma jobdux ir-regola, aħna l-physics jew regola. U jien għattilkom isma' dan għandu angular biex ikollok angular acceleration għandek couple. Mela jekk dal-steering qed taraħ jagħmel angular acceleration anke bit waħda, suppost hemm couple fuqu. Mela x'imkien f'dak l-steering, anke meta tkun qed iddawru bit waħda, hemm force oħra li hija equal to the force that you are applying and antiparallel. Fejn taħsbu li qiegħda l-force l-oħra? Bil-force hemm force oħra kontra dik il-force li qed nagħmel jien. Bil-force. Bil-force irid ikollok couple. Isa. Fis-center eżatt li jiġri huwa dan. Li kieku l-steering mhux imqabbad ma l-steering column, kieku għandi xejn tont. Immaġinaw dal-steering sawa, kieku mhux imqabbad u jien nipprova nagħmillu force fil-ġemp hawn, infatti jekk jiġri idur u fl-istess ħin jimxi in a straight line. Imma l-steering imqabbad ma l-steering column li hija biċċa importanti ħafna tal-karozza. Li għax l-steering column imbagħad titrasmetti it-turning effect lil wheels u x'vera. Allora li jiġri hu meta inti tipprova tiġbed bit waħda, vera ħa toħloq angular acceleration u fl-istess ħin tipprova toħloq linear acceleration, imma l-steering column ħajżommu l-steering mela x'ġara. L-steering qed tipprova tellaw il fuq, imma l-steering column ħajżommu milli jitla' l fuq. Mela li jiġri hu li l-steering column it will exert a force which is equal and opposite to the force that you are exerting. And as you can see, in fact, that's a couple. Araw, two forces which are equal and antiparallel. Imkien manna fid-definition ta' couple li two forces should be on either side of the center. Infatti mhijiex. Anke jekk ikollok oġġett għandu center hawn u għandu żewġ forces hekk, dik ukoll hija couple, dik ukoll hija couple. Alright? Ġifieri id-definition ta' couple hija two forces which are equal and antiparallel, full stop. Ġifieri dik hija couple. Mela taraw la għandi angular acceleration biss, sinjal li couple irid ikun hemm, u infatti hemmhekk hemm couple. Issa għamlu daqsxejn distinzjoni. U waraw għaliex ħafna drabi jgħidulkom importanti żommu żewġ idejn fuq l-steering. Araw, jekk iżżomm iż-żewġ idejn fuq iż-żewġ naħat tal-steering, dak huwa l-couple. Fil-waqt li jekk tagħmel id waħda, dan huwa l-couple, araw x'inhi d-differenza. Jekk insib it-torque ta' dan il-couple tal-ewwel wieħed hija F times the separating distance li hija 2R. Imma dan it-torque huwa F times R, għax dik hija separating distance, qed taraw għaliex ħafna drabi jgħidulek jekk tista' żżomm iż-żewġ idejn fuq l-steering aħjar, għax it-torque li tkun qed tipproduċi huwa ikbar. Mela allura ħajkollok ovvjament iktar kontroll fuq l-steering tal-karozza. Illum qed inqażżu ta' nużaw id waħda biex indawru l-steering, għax illum għandna l-power steering. Ġifieri hemm sistema fejn tgħinek biex inti ddawwar ir-roti. Meta konna qabel mingħajr power steering kelli jien waħda karozza bla power steering fil-bidu. Bla power steering mhux se taqbad u ddawwar ir-rota hekk bil-karozza wieqfa ta' m'għandekx li ċken ċans. Ġifieri f'dak iż-żmien konna nużawhom iż-żewġ idejn għax konna nkunu rridu nużaw it-torque biex fil-verità ndawru r-roti. Infatti jekk taraw min idawwar it-trakkijiet, avolja trakkijiet illum bil-power steering ukoll, ma speċjalment jekk taraw trakkijiet antiki, tarawhom idawru biż-żewġ idejn, għax ovvjament ikun iridu joħolqu torque kemm jista' jkun kbir biex ikun jistgħu jdawru r-roti. Alright? Fimniha dil-biċċa. Alright? Ħantikom issa l-aħħar eżempju, u nkunu għalaqna dil-biċċa fuq couple u fuq torques, alright? Ħanieħdu l-eżempju issa ta' frisbee. Frisbee huwa naħseb xi ħaġa perfetta biex nifhmu. Fejn inti għandek oġġett li dal-frisbee meta jitlaq minn idek ikun jibda idur fuq innifsu mela għandu angular acceleration u fl-istess ħin għandu linear acceleration ukoll. Taqblu miegħi. Huwa każ fejn qed nagħmlu iż-żewġ tipi ta' accelerations flimkien inti twadbu l-frisbee idur mela jibda kien wieqaf mela kellu angular acceleration fl-istess ħin għandu linear. Mela suppost, alright, dan il-frisbee għandu żewġ affarijiet suppost. Għandu couple fuqu u għandu wkoll resultant force. Taqblu miegħi? Suppost għandu couple u għandu resultant force. Ejja niċċekkjaw jekk hux vera jew le. Meta inti twaddab il-frisbee, kull ma tagħmel inti toħloq biss force on one side. Aħna hekk nagħmlu. Mhux hekk kulħadd iwaddbu l-frisbee, force on one side u daqshekk. Tgħidli stenna ftit, tgħidli mela fejn għall-couple. Araw kif vera. Jekk jiena nagħmlilkom hekk. Dan trik diffiċli biex jiġi f'moħħkom waħdu nafu għax ovvjament ma' żmien taqra ħafna u titgħallem. Jekk jiena nagħmel hekk impinġi żewġ forces at the center equal and opposite. Taqblu miegħi li dan li the diagram on the left hand side u diagram on the right hand side they are practically the same. Mhux vera, they are equivalent. Għax jekk jiena nagħmel force u force kontra mis-center, dawk ħajkanċellaw il-xulxin. Imma raw, di tfehmna eżatt dak li qed nagħmlu. Jekk tħarsu hawnhekk għandi couple, qed taraw? And that couple is necessary for the object to provide angular acceleration. But at the same time, look, at the same time, I have a resultant force which is pulling the center of mass of the object, and that is what is provoking the linear acceleration. Mela suppost issa konvinċejtkom li kull darba li jkollok oġġett li qed jagħmel angular acceleration dak għandu couple fuqu, meta taraw oġġett li qed jimxi jagħmel linear acceleration dak għandu resultant force fuqu, jekk taraw oġġett li qed iduru fl-istess ħin miexi in a straight line, mela għandu angular and linear acceleration at the same time, therefore that object should have a couple and the resultant force. Fimnija hawnhekk? Naħseb tħalt ħafna fid-dettall għalija. Issa. Qabel ma nagħlaq illum, x'ħanagħmlu? Ħanitkellmu fuq xi ħaġa oħra. Ġifieri issa ma' din il-lista fejn marret il-lista sa ilha ftit il fuq. Alright? Fejn kellna force, resultant force in linear, flok resultant force in angular għandna bżonn torque. Alright? Għandna bżonn torque li hija force times the perpendicular distance. Alright? Qegħdin narawha. Mela flok force għandna bżonn torque in rotation. Mela għandna xi ħaġa oħra li biddilna. L-aħħar ħaġa li ħanitkellem fuqha. Għada ħanitkellem fuq Newton's second law in rotation. Għada ħan nitkellem fuq Newton's second law on rotation. Issa tafu li Newton's second law. Suppost studjajtuha u għamennija fi questions ukoll. Newton's second law says that the rate of change of momentum is directly proportional to the force. U ġvera konna ngħiduha. So in Newton's second law, we mention momentum. So is there a momentum for rotation? Yes, there is a momentum for rotation. So if I have an object of mass m having a velocity v, which is away from the center a distance r, and it is going around in a circle, when għandna angular velocity omega, alright? The definition, dejjaq nibda jekk imma llum hekk ħanamilha, the definition of angular momentum, which is the momentum when an object is rotating, the angular momentum is defined as the product is the product of its linear momentum and the perpendicular distance from the axis. Mela, x'inhu huwa mela kif insibuh l-angular momentum? L-angular momentum insibuh billi nagħmlu l-product mela multiplication of the linear momentum. Mela, jekk għandi particle miexja b'linear velocity v tangent, ovvjament tangent, u għandha mass, il-linear momentum insibuh billi nagħmlu mass times velocity, u ġvera. Mela linear momentum mass times velocity bħas-soltu, and the perpendicular distance from the axis of rotation times r times the perpendicular distance from the axis of rotation times r. Sawnek alright? Issa. Imma jekk nirranġa ftit din il-formula, arawa. V hija omega r, u ġvera. V hija omega r, therefore, instead of V I can write omega r times r. Jekk nirranġa ftit di, attenti ħarsu li whiteboard please, għandi m, r u r jiġu r squared omega. Araw daqsxejn. Mela l-angular moment huwa mr squared. Mr squared x'inhu? Diġà semmejnieh. X'inhu mr squared? Min jiftakar. Mr squared huwa isa. Mr squared huwa il-moment of inertia. Tiftakruh? Mr squared huwa l-moment of inertia ta' din il-particle. Meta jkollok particle waħda, il-moment of inertia nagħmluh il-mass times the radius squared. So that is the moment of inertia times omega. The symbol of angular momentum tgħidu li xilala ma nafx għaliex huwa capital L. Ma nafx għaliex huwa capital L, m'għandix li x'kien idea. Alright, imma dik huwa s-simbolu. Jekk qed tinnotawh, il-angular momentum mela the momentum of an object which is rotating on itself, actually it's very similar to the linear momentum but using the physical quantities of rotation. Infatti, il-linear momentum li għamilna diġà u użajtu hintom ukoll, kellu simbolu ta' P. U konna nagħmluh mass times velocity, le? L-angular momentum ara flok il-mass qed nużaw I, kif qed nagħmlu infatti s-soltu, u flok il-velocity, il-linear velocity, nużaw l-angular velocity. Ġifieri, għajna dejjem bl-istess regola biex naqilbu minn linear għal angular għal rotation, kull ma t-nagħmlu huwa qed naqbdu is-simboli li konna nużaw f'linear u minn flok qed nużaw the rotation counterpart of them. Ġifieri għal momentum qed nagħmlu l-istess ħaġa. Flok massu velocity qed nużaw I u omega. Alright? U hekk jiġi l-angular momentum. Issa, attenti ftit għall-imbirek angular momentum. Alright? Għal-unit. Għax għandu unit vera twil. U ħafna drabi apposta, intom normalment, il-units jagħtu kasom, imma mhux daqskemm kienu jagħtu kasom flow level. Alright? Fis-sens jekk ma tagħmlux il-units titilfu marki. Ma ġieli flow level kontu titilfu nofs il-marki jekk tinsew il-unit. Fil-unit ta' angular momentum fl-A level, normalment dan ikollu marka jew ġiex marki għalih biss. marka jew ġiex marka għalih biss. Għaliex? Għax il-unit tiegħu jiġi. Il-unit ta' I kilogram meter squared. Għax mass times radius squared. U l-unit ta' omega li huwa radians per second. Araħ kemm hu twil. Alright? Radians per second. Ġifieri, normalment ikun twil ħafna il-unit ta' angular momentum. Alright? Kilogram meter squared radians per second. Sawnek alright? Issa, meta jkollok oġġett li qed idur fuq innifsu jekk tiftakru sew meta konna minni għal flinear momentum jien kontattilkom although linear momentum is a mathematical quantity, actually it shows how difficult it is to stop a moving object. So the larger the linear momentum, the more difficult it is to stop it. This is similar, this also is true for angular momentum. The larger the angular momentum of an object, the more difficult it is to stop it from moving. Therefore, if you want something, bħalma sammejna diġa flywheels, that you need them, once you rotate them, you need them to continue on rotating without stopping, and it's difficult to stop them. Therefore, you need a large angular momentum. So the larger I and the larger omega, the larger the angular momentum of that object. U għalhekk infatti ħafna drabi we opt to have a very large moment of inertia. Biex inti kif tibda d-dawru ftit, diġa jkun diffiċli ħafna biex twaqfu. Alright? Issa, one last thing about angular momentum, ħanurikom ftit in-noti. Since angular momentum is a pseudo vector, it's a vector which is very similar to angular velocity, so it's a vector which is rotating, alright, mhux vector dritt, huwa vector li qed idur. Ir-regola biex tpinġi id-direzzjoni tal-angular momentum vector hija l-istess bħalma konna minna ta' omega, ġifieri tridu tużaw il-right hand grip rule. Ġifieri if the object jekk tippruvaw fuqha, mhux se nurijilkom hekk għax il-direzzjonijiet jiġu ħżiena meta nkunu qegħdin bil-ġismu. So if you try your right hand grip rule, alright, if the object is moving in that direction, in fact the thumb will show you that the direction of the of the vector of the angular momentum should be vertically upwards. In fact, as you can see here, the direction of the angular momentum and the direction of the angular velocity, in fact, they are the same, bil-force. Għax inti, għalhekk infatti l-L għandu l-istess direzzjoni ta' da, għax it-tnejn għadin ovvjament fl-istess direzzjoni mela t-tnejn ħajkollhom l-istess direzzjoni tal-vector. Again, ma nafx kemm ħajsaqsijilkom di il-biċċa imma jiena xorta nsemmija għax hija importanti. Alright, mela, ħanurikom daqsxejn minn noti, mela għandkom dil-biċċa hija fuq angular momentum, attenti li tkunu tafu id-definition tal-angular momentum. Alright, u l-formula, turning effect of a force, di diġa tkellimna fuqha, moment of a force, u mbagħad hawnhekk inkompli fuq il-couple, għandkom id-definition of a couple, u għandkom id-definition of a torque, torque due to a couple in the fejna. The moment of a couple is called the torque. The moment of a couple is called the torque. U għandkom il-formula ta' torque. U għamnek għandkom dawk iż-żewġ examples li semmejtilkom waqt il-lecture illum. Alright? Biex nispjegalkom li jekk għandek angular u linear acceleration mela jrid ikollok both a torque and a resultant force. Alright? Mela. Illum ħani qafaw għax mhux se nibda in-next part għax inkella nidħlu f'biċċa oħra. Imma għada li ħanagħmel huwa ħansemmi x'kont se ngħidilkom. Ħansemmi il-second law, Newton's second law in rotational form, alright? U mbagħad inkunu nistgħu nibdew naqdu kollox għax imbagħad inkunu qlibna kollox minn linear rotation. Alright, inkunu qlibna kollox. Mela, ħanħallikom hawn narakom għada jiena. Okay? Ciao ciao.
Thank you, sir.